So we're back to solving equations with square root property. With all that I experience under our belts, we can tackle any one of these, no matter if there's positive or negative. So if this is given, x would be equal to plus or minus the square root of negative 10 by square root property, and then I can proceed to say x equals plus or minus I times the square root of 10 by definition of negative radicals. Okay? Easy, right? Everything else remains the same. Here, this one adds a little complication. That's good because it was getting boring. I could divide both sides by 5, so that would give me x squared equals negative 13 over 5. That's by kill the coefficient theorem. And then I can say x equals plus or minus the square root of negative 13 over 5. That's by square root property. And then this is really negative. So I can say this is plus or minus I times the square root of 13 over 5 by negative radical definition. There you go. Piece of cake. This one, interesting, we had to get rid of that 5 first so that we can apply SRP. SRP doesn't apply when there's stuff hanging in there. You can only have a 1 in front of the coefficient on the degree 2 term. Okay, how about this one? This one even adds more complications. You got the 5 and you got stuff in there. No worries. This is a piece of cake. We've got x squared equals negative 7 over 5 by kill the coefficient. I've got x minus 1 is equal to plus or minus the square root of negative 7 over 5 by square root property. And that's the perfect medicine to get rid of a square of blah. You just do the square root property. And now you're almost done. You want to isolate x all by itself, so you would add a 1 to both sides. 1 plus square root of negative 7 over 5. Cancellation law of addition and minor axioms. There you go. Added 1 to both sides. And now we've solved that. We have your two solutions, your degree 2 equation. One of them is 1 plus the square root of that. The other one is 1 minus the square root of that. We can use our I verbiage, our I axioms here to figure out the square root of a negative radical. It would be 7 over 5. The negative one comes out as, well, as I. That's by negative radical. And there you go. That would be a clean, nice solution. Okay. Sometimes some people will ask you, "Oh, you got to rationalize the denominators." You might, but that's not a big deal right now. We cross that bridge when we get there. This is nice. X is all by itself on one side, and there are no x's on the other side, and everything is perfect and logical. All right. What about this one? No, that's too easy. That's too easy. Which one you want to do, that one or that one? Let's just do this one. We'll finish off with this one. So this one's got 2 there, and so we won't let that stop us. We can divide both sides by 2. That's killing the coefficient, and then we can get rid of that 2 by using the famous square root property. Square root property. I can subtract 4 from both sides. Negative pi over 2, cancellation law of addition, and some other things. And then I can either take this one out, or I can divide by 3. I'm going to kill the coefficient. Negative 4 plus or minus the square root of negative pi over 2 all over 3 by killing the coefficient. I could take out the negative, and that becomes negative 4 plus or minus I times the square root of pi over 2 all over 3. That's by definition of negative radical. Beautiful. Step by step solving of degree 2 equation using a couple big ideas: square root property and complex numbers here. The fancy name for these I's is complex numbers. These are big ideas. Alright, I think we'll stop here today. We'll see you guys here next time. Peace.